Today I will be talking about Hess's law. We have to clear out some background information before we can get into Hess's law. It is important to understand that enthalpy is an extensive property, meaning that the amount of reactants and products affects the change in enthalpy of a reaction. This may be hard to grasp at first, so I will demonstrate. Imagine I have one stick of dynamite. I ignite the stick of dynamite and it explodes. When it explodes, it releases 1000 kilojoules of energy, which I will represent by saying that delta H is negative 1000 kilojoules. So, one stick of dynamite releases 1000 kilojoules of energy. How much energy do you think 2 sticks of dynamite will release? It should release 2000 kilojoules of energy since I have doubled the amount of dynamite. What I'm trying to show you is that changing the amount of dynamite also changes the amount of energy released by the same factor. When I double the amount of dynamite I have, I also double the amount of energy I can release. So now, let's take a look at this reaction. This is the reaction for the combustion of 1 mole of coal. In a combustion reaction, 1 mole of coal will release 394 kilojoules of energy. So, imagine that I doubled the amount of coal, oxygen, and carbon dioxide in this reaction. How much energy do you think it will release? It would release 788 kilojoules of energy. Just like with dynamite, changing the reaction by a certain factor will also change the energy released by that same factor. In this case, doubling the reaction doubled the amount of heat released. Now, you may be wondering about endothermic reactions. Don't worry, endothermic reactions will follow the exact same rules. I'm going to go over one last thing. Reactions are reversible. This means that you can make coal from carbon dioxide. However, it is important to understand that reversing a reaction will turn the delta H value opposite of the original value. When we combusted 1 mole of coal, we released 394 kilojoules of energy. Now, if we want to form 1 mole of coal using the reverse reaction, we would need to absorb 394 kilojoules of energy. In other words, delta H for the formation of coal is positive, which indicates that energy is absorbed, not released. Now that we got the background information cleared, we can move on to the idea of Hess's law. Sometimes reactions occur over a series of steps rather than just one step. I'm going to use letters to represent reactants and products. For example, we may have the following reaction, where A turns into D. What isn't shown are the steps needed for A to turn into D. A actually turns into B. Next, B will turn into C. After that, C turns into D. So overall, we get A turning into D. You may be wondering why we don't show B or C in the overall reaction. The reason so is that even though B and C are produced, they are also consumed. For that reason, they don't appear in the overall reaction. It is important to note that each step has its own delta H value. Hess's law states that the sum of the delta H values of each step will give you a delta H value for the overall reaction. In other words, A turning into D is the overall reaction, and its delta H value can be found by adding up the delta H values from its steps. So, try to find the delta H value for the overall reaction. Hopefully you got positive 14 joules. When you're solving Hess's law problems, you do something similar to that, but it usually won't be that straightforward. You will typically have to manipulate the steps in order to find the overall delta H value. Remember the information I taught you earlier about doubling the reaction or reversing the reaction. You'll be using those techniques to solve for Hess's law problems. Alright, let's try to do this one together. This may seem a bit intimidating since there's coefficients and 5 different letters, but I'll show you my approach and thinking process towards this problem. Think of this as the overall reaction, the one we're trying to solve for, and these as the steps. Remember the previous slide. To find delta H of the overall reaction, all we had to do was add the delta H values of the steps. But there's an issue. If I combine all these steps together, I will end up with this overall reaction. This is not the overall reaction we're trying to find delta H for. As you can see, they are quite different. So this 275 kilojoules is not the right answer, since it isn't for the right reaction. Let's try a different approach. By taking a look at the overall reaction, we can see that D and E will be reactants, but in the steps, they are products. So we have to figure out a way to get them on the reactant side. Earlier, I mentioned something about reversing reactions. That's what we have to do in order to get D and E on the reactant side. So let's do that. However, I mentioned that delta H will become the opposite value if you reverse the reaction. When we reverse these two reactions, we must also change the delta H value accordingly. Let's do that as well. Now, let's try again and combine everything. This is looking better than before, but there's still an issue. The reaction is still different, since the coefficients here are twice the amount than what we're looking for. We need to get from 2 to 1. Luckily, there's a way. Earlier, I mentioned that changing the reaction by a certain factor will also change the delta H value by that same factor. We can have both our reaction and our delta H value. After doing that, we end up with the exact same reaction we're looking for, as well as the delta H we need. That's our answer. What we did was that we manipulated these steps and their delta H values as we tried to recreate this overall reaction. Once we got that reaction, we added up all our modified delta H values to get the answer. So, that was an example of a Hess's law problem, as well as how it may look like. I'll leave this one for you to practice. Be warned though, there is no more letters. You're seeing molecules instead, which may make things more messy. Remember what you've learned and good luck. Pause and try to solve for the delta H value. I hope you got the same answer I did. That's all for today. Thanks for sticking with me. Goodbye.